I'm Sakin Vicharan, the team lead of the project. Our platform addresses the growing threat of ransomware attack on operational technology system like SCADA and PLC, which can seriously distribute the factory operations. The goal was build a smart real-time solution to detect and respond to these threats automatically. We focused on six key areas: AI-based ransomware detection using federation learning, automation in automated incident response through the SOAR, real-time monitoring and secure backup, a storage backup and recovery system, advanced threat intelligence and integration, and secure communication and logging. Together, these features create a complete protection platform for the critical infrastructure. We used an agile development model divided into three sprints, which help us manage complexity and track progress in a structured way. Each sprint focused on the major part of the project. In sprint 1, we conduct in-depth research, finalize our architecture, and select right tool stack. During sprint 2, we implement the scope features, the detection engine, monitoring APIs, and SOAR automation. In sprint 3, we integration all modules and testing system with real ransomware simulation using Kali Linux and Metrosploit. Our team consists of 6 members. I manage the project as team leader and contribute the backend automation. Savindu built a front dashboard with real-time alert. Vihanga led the backend system integration. Disha ensure network security and compliance. Dulan implement the AI models and Pasidu handle the testing platforms analyze. This structure teamwork allowed us to deliver secure, intelligent solution that ready for the real world OT use. Thank you. I will hand over the presentation to Savindu.
Thanks, Sakiru. In this project, I developed the real-time OT dashboard using React and Fast API, focused on monitoring critical OT metrics including CPU usage, memory, temperature, and network traffic. The system collects and updates data every 5 seconds, giving operators live visibility into system performance and early warning signs of failure or attack. The dashboard was designed with a clean, lightweight interface, ensuring it performs reliably in industrial settings while remaining easy to navigate. These real-time insights play a vital role in supporting decision making during abnormal behavior or ransomware threats. Alongside monitoring, I implemented a smart alert system that automatically classifies alerts by severity: high, medium, or low. These alerts appear in a rolling log with real-time updates and are fully integrated with the backend SOAR engine via Fast API. I also enhanced the interface by improving font scaling, color contrast, and alert spacing, making sure alerts are both visible and actionable. These improvements help reduce alert fatigue and ensure that users can respond quickly and effectively. So now I'd like to hand over to Vihanga to present his part.
Thank you, Savinu. Out of the six proposed features for our system, we were able to successfully implement prototype versions of three features. The first feature is the AIRS system, short for Automated Incident Response System. Our Automated Incident Response System is designed for critical speed. When abnormal or malicious behavior is detected, it reacts in milliseconds, isolating infected OT systems, halting risky processes, triggering system rollbacks, and even launching just in time backups. Everything is pre scripted and autonomous, built using Python, using libraries like psutil, subprocess, and shuttle, ensuring zero delay in high risk environments like SCADA and PLCs. This not only limits damage but enables rapid recovery without manual effort. The second feature is the SOA integration. Our SOA engine runs custom playbooks that coordinate backup, isolating, alerting, and rollback. Whether it's pausing a PLC command or sending real time alerts with device level forensics, SOA handles it all through predefined workflows. We use tools like Shuffle and Fast API to create these low latency workflows, which remove the need for manual intervention. It reduces response time from hours to seconds and ensures full traceability through SQL logs. This platform is built using modular Python microservice architecture with fast API, MQTT, ERK stack, and AWS S3. It's designed to be lightweight, cloud integrated, and fully compatible with OT protocols. Now I will hand over my slide to Nisa. Thank you.
Thanks. Now I will walk you through Unified OT Ransomware Security Framework. I focused on securing all operational technology communications by using strong encryption. I deployed TLS 1.3 with AES 256 to make sure data stays private and can't be tampered with. I also set up automated compliance monitoring to meet important standards. This includes detailed audit trails so we can track everything and ensure accountability. To catch threats early, I developed anomaly detection tool that watch for unusual activity in key areas. I also check hardware sensors for temperature or voltage spike and keep an eye on network traffic for sudden burst that might signal an attack. I also did real-time monitoring backend in that my system collects preliminary data every 5 seconds, tracking CPU, memory, temperature, and network activity. I set up a three-level alert system, which is high, medium, and low, so we can prioritize responses effectively. Plus, all logs are secured with cryptographic signature to prevent tampering. Finally, I tested the system with real-world simulation using Kali Linux penetration tests, Metasploit ransomware payloads, and custom malicious scripts. The automated defenses I put in place can contain threats in just 8 milliseconds and trigger instant backup recovery to minimize downtime. Thanks.
Thank you, Tisha. Hi everyone, I will be presenting our simple local ransomware detection model. This system is designed for local edge environments like personal PCs or small industrial systems where full-scale AI deployment or cloud-based security may be not practical. This model works in four main steps. First, we collect the local data, local system behavior, particularly CPU usage, file modification events. Then we label this data and train a lightweight machine learning model in logistic regression to recognize suspicious activity. In the live phase, the system runs a real-time monitor that reads these same metrics and uses the model to decide whether the system is behaving normal or showing signs of ransomware attack. If any abnormal activity like high CPU usage combined with rapid file system changes, the user gets an immediate alert. The solution is intentionally lightweight with forces on privacy as no data leaves the device. It is suitable for personal use or OT environments where quick reflections and simplicity are more important than complex cloud-based analysis. Our goal is to give the early warning to the user so he can take actions before the encryption begins. Now I will pass it on to Pasindu for system testing. Thank you.
Thank you, Dolan. Hi everyone, I'm Pastor Fernando and I served as the system tester for Sprint 3. During this sprint, my main responsibility was to validate how well our ransomware detection system performs under real world conditions. To do this, I created simulation scenarios using custom .bat scripts that replicates ransomware behavior such as rapid file spamming, and high CPU usage. So these simulation helped us evaluate how early and accurately the system can detect threats. So once these simulations were complete, I focused on analyzing the detection model performance. I evaluated key metrics including precision, recall, F1 score, and false positive rate. So these metrics gave us a clearer picture of how reliable the model is, especially in distinguishing actual threats from normal system activity. So overall, the result showed a strong improvement over the sprint 2, particularly in reducing false positive and improving detection precision. So now I'll give you a brief summary about the presentation. So the final summary. So wrapping up, our project delivered a unified ransomware protection and incident response platform tailored for OT environments. So we developed a lightweight machine learning based detection tool that runs locally on edge devices, catching early ransomware activities like CPU spikes and rapid file changes. So alongside that, we enhanced our source system to automatically isolate threats, trigger rollbacks, and maintain secure auditable logs. So we also improved the user interface to make alerts clearer and easier to act on in critical scenarios. So based on the feedback that we got from the client, we refined the model's clarity, improved the UI, and ensured the deployment readiness. So looking ahead, our next steps are to expand the detection to memory and process-based threats, integrate with SIEM in platforms, and continue improving the system scalability and the user experience. Thank you.